Welcome, friends. So, we are discussing network theory. So far, we have finished 5 modules, starting with the fundamentals of electrical engineering, then AC networks, then three-phase AC networks, and thereafter we have seen different theorems. Now, this module we are presently at module 6, which is all about a new topic, two-port network. Now, what is two-port network? Now, any network has one input port and one output port. So, in this way, any network can be said as a two-port network. So, both the ports, that means input port has a voltage and current, and output port has also got a voltage and current. So input voltage, input current, output voltage, output current. So this module or this chapter is the study of interrelationship between these four variables or amongst these four variables. We consider any two variables independent, and remaining two variables we represent them as a function of those independent variables. So let us go straight into the subject. So let us consider figure 1. We have a network. We have an input port and we have an output port. Input port has a voltage of V1 and current of I1, and output port has a voltage of V2 and current of I2. So we have four parameters, V1, I1 as my input parameters, and also we have V2 and I2 as our output parameters. Now when these currents, both currents I1 and I2, when I1 and I2 are taken as independent parameter and voltages V1 and V2 are represented as a function of I1 and I2, so this represents one specific parameter which is called Z parameter or impedance parameter or open circuit parameter. Moving on, when voltages, that means input voltage and output voltage, is taken as independent parameter, and the currents I1, I2 are taken as dependent parameter, and therefore that current is represented as a function of voltage, then that representation is called Y parameter representation or admittance parameter representation or short circuit representation, short circuit parameter representation. Next, if we have input voltage as independent parameter, or rather it is dependent parameter, and V2 and I2 is the independent parameter, then that representation is called, that means V1 I1, so input parameters is represented as a function of output parameters. Okay, so here V2 and I2 is the independent one, and V1 and I1 is the dependent one. So that representation is called T representation or T parameter representation or ABCD parameter representation. Lastly, if we have if you do some mixing, okay, that means input voltage and output current as an independent parameter, or rather no, it is a dependent parameter. Again, V1 and I2 is the dependent parameter, and input current and output voltage is the independent parameter. Then this representation is written in this way: V1 I2 as a function of I1 V2. So we are doing something mixing between input and output terminal. So we pick anyone from input and anyone from output as a dependent and remaining two as a independent. Then it is actually some mixing is done. So that is why it is called H parameter or hybrid parameter. It is called H parameter. This representation is called H parameter representation or hybrid parameter representation. So these are the four parameters we shall study. First we have impedance parameter, then we have admittance parameter, then we have ABCD parameter, then we have H parameter. So we have these four parameters to study. So let us define one by one. Let us say we have definition of Z parameter. So as it is already mentioned that V1 and V2, that is the input voltage and output voltage, is a function of I1 and I2. So if I represent V1 V2 in this fashion, that multiplied into again that current vector I1 I2, so this term actually, this term is nothing but Z. This term is nothing but Z. Okay. So dimensionally, actually voltage is equal to something into current, then that something must be of dimension of ohm. So that is why we consider this something is Z actually. So now if we want to arrange in terms of matrix form, then this it becomes a 2 cross 2 matrix. So first term will be Z11, second term will be Z12, third term will be Z21, and finally the last one will be Z22. So it will be a 2 cross 2 matrix. So if you now expand, my first equation will become V1 is equal to Z11 I1 plus Z12 I2. And if you expand the second row, the second equation will become V2 is equal to Z21 I1 plus Z22 I2. So these two equations are called our fundamental equation to define Z parameters. So exactly it is written here. V11 or rather V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. These two equations are the fundamental relation representing voltage and current relation. Now how to define these Z parameters? There are 4 Z's actually. So how to define Z parameters? So in order to define Z parameters, let us first make I2 equal to 0. Let us first make I2 is equal to 0. So if I2 equal to 0 from this equation, so from this equation if I2 is equal to 0, then immediately we can write Z11, immediately we can write Z11, it will be V1 by I1 with I2 is equal to 0. Now V1 by I1 is equal to Z11, it is only true when I2 equal to 0. And similarly Z21, that will be is equal to V2 by I1. Now these two equations are only true when I2 is equal to 0. So you need to first, so it is must to make output port open circuited. Okay, that is the must thing. Output port you must make it open. So Z11 becomes V1 by I1 with I2 is equal to 0. And Z22 becomes V2 by I1 with I2 is equal to 0. Okay, so these are the definition of Z11 and Z21. Now from the second equation, now if we do the reverse thing, that means we make I1 is equal to 0. We make I1 is equal to 0. That means we need to open the input port. We need to open the input port. So from the second equation, or rather both the equation, we will get Z12. We will get Z12 is equal to V1 by I2 with I1 is equal to 0, and Z22 becomes V2 by I2 with I1 is equal to 0. So please pay attention that this Z12 is equal to V1 by I2 and Z22 is equal to V2 by I2. These two are only true when I1 becomes 0. Otherwise it is not possible. So Z12 becomes V1 by I2 with I1 is equal to 0, and Z22 becomes V2 by I2 with I2 becomes 0. So these are the definitions of these four parameters, Z parameters. Now if you observe closely that the dimensionally all the Z parameters have voltage by current, that means all the parameters having unit of ohm, right? This is actually the unit of all Z parameters. Another interesting observation, we are defining them either making I1 is equal to 0 or making I2 is equal to 0. That means in both the case we are making currents equal to 0. That means we are making open circuiting. We are making open circuiting both the terminals, input port and output port. Okay, so we are making open circuit both the terminals. That is why Z parameters are also called open circuit parameters. Z parameters are also called open circuit parameters. Now what are the applications? Now in electrical engineering we encounter a very common phenomena like fault. So these Z parameters are used in fault parameter calculations. Z parameters are used in fault parameter calculations. Now if we now want to represent these two equations, that means V1 is equal to Z11 I1 plus Z12 I2, and then V2 is equal to Z21 I1 plus Z22 I2. So if we now want to represent these two equations in terms of a equivalent circuit, then this figure 2 represents that. Let us say we have our input port V1. Okay, let us say we have an input port V1. This is my input port V1, which is injecting a current I1, which is injecting a current of I1. Now when it injects a current at I1, some drop is coming, which is Z11 I1, so that current must be flowing through a impedance Z11. So that is that impedance Z11. And another part or another impedance is Z12 I2. Now if V1 is actually Z1 to I2. That means what? That means what? You closely observe, this V1 represents the parameter of input side and I2 represents a parameter of output side. Okay, so input side is dependent on some output parameters. That is why this voltage source or this voltage drop Z1 to I2 is represented by a dependent source. This is represented by this dependent source, voltage source, which is magnitude is equal to Z1 to I2. That means the magnitude of this voltage source is dependent on the secondary current or output port current. In the same way, if we consider our output port as V2, which is having voltage V2 and it is injecting some current I2. So this parameter or this part Z2 to I2 is the voltage drop in the impedance Z22. And again, this V2, you see, this V2 is a function of I1. That means output port parameter is dependent on the input port parameter. So due to to represent that thing, we represent this voltage source by a dependent source. That means this voltage source in the secondary side is dependent on some current on primary side or input side. So this represents the equivalent circuit of Z parameters. Now some additional information. Suppose if we have a network like this, what is this? It is a T network. It is having a T. You have a T network. So if you have a T network like this and these three elements are represented in ohm, then equivalent Z parameters is represented by this. You don't need to solve, you can directly use this result. What is that? Z11 is equal to Z1 plus Z3. What is Z1? Z1 is this arm and Z3 is this arm. Z11 plus Z3. And Z22 becomes Z2 plus Z3. Z22 becomes Z2 plus Z3. And Z12 and Z21 are both Z3. Z11 and Z21 are both Z3. So for an example, if a T network is like this, 2 ohm, 5 ohm and 1 ohm, so its Z parameter should be 2 plus 1 3, 1 1, 5 plus 1 6. So Z parameter is represented by this 3 ohm, 1 ohm, 1 ohm, 6 ohm. So you can directly use this result. Now moving on, if we have a network or a part of the network is connected in this fashion, we have a network 1 and network 2. Now this type of network, this connection is called series connection of two networks. This is called series connection of two networks. So suppose that network 1 having an impedance or Z parameter Z1 and network 2 having a Z parameter Z2. So the equivalent network, if you represent these two networks by a single network, it is equivalent network. So the Z parameter of that equivalent network will be the summation of Z1 plus Z2. So let me repeat one more time. So if you have two networks connected in this fashion, it is called series connection between two networks. So now you have two networks. Now if you represent these two networks by a single equivalent network, so the equivalent Z parameter of this equivalent network will be is equal to Z1 plus Z2. What is Z1? Z1 is the impedance parameter of network 1 and Z2 is the impedance parameter of network 2. So this is the rule. So you can straight away follow this relation if you have encountered something like this. Two networks are connected in series. With this final thing, okay, so now let us quickly visit, or let us quickly discuss the different nomenclature of this Z11, Z21, Z12 and Z22. Now Z11 is called driving input impedance. Why? Because it is V1 by I1, it is V1 by I1 with I2 is equal to 0. So here it all represents input parameter. So it actually from the input port it drives the entire network. From the input port it drives this impedance drives the input entire network. That is why it is called driving input impedance. In this way we can say that Z22 V2 by I2 it is called with I1 is equal to 0. Since it all represents the output parameter, output port, so it is called driving output impedance. It drives the entire network from the output side. That is why this name comes. And now let us coming to the Z22. Sorry, not Z22, Z21. Z21 is equal to V2 by I1, V2 by I1 with I2 is equal to 0. Now why this name forward transfer impedance? Now let us say we have input port as 1. Let us say we have input port as 1 and output port as 2. Output port as 2 and signal is flowing from 1 to 2, from input to output. That is our conventional signal direction. From input port to output port, it is our conventional signal flow. Now in this case Z21 you see it is actually V2 by I1. That means if you can correlate or if you can analyze or if you can think this dimensionally, this equation or this ratio as output by input. That ratio is output by input. So output is as V2 and input as I2. That means signal is flowing from 1 to 2. That means input to output. That means signal is flowing in the forward direction. And that is the meaning or that is the significance of this term forward. And why this transfer? Because it represents or it is reflecting two parameters. Two ports rather. It is input to output. Signal is transferring from input to output. That is why it is called transfer. Simple. Now on the other hand, if you consider Z12, it is V1 by I2 with I1 is equal to 0. With I1 is equal to 0. So you see now in the numerator we have output. This is V1 as output, right? And I2 as input. So actually what happens is that now signal is flowing in the reverse direction. Okay, signal is flowing in the reverse direction. That is why it is called reverse transfer, because of two ports involved, and impedance because dimensionally it is voltage by current. That is why it is reverse transfer impedance. So we have encountered four nomenclature. First of all, driving input impedance. Driving input impedance, which is Z11. Next we have driving output impedance, which is Z22. Then we have forward transfer impedance, Now this is actually forward transfer impedance, that means V2 by I1, V2 by I1 with I2 is equal to 0, and that is actually is equal to this one, actually Z21. And finally we have reverse transfer impedance, actually it is V1 by I2 with I1 is equal to 0, and that is we call as Z12. So we have encountered this 4 nomenclature primarily. So this is actually Z parameter, definition of Z parameter and different salient properties of Z parameter. It is called open circuit parameter because we need to define different Z parameters by open circuiting them. You need all the Z parameters having unit of ohm. The primary application of the Z parameter in fault parameter calculation in power system, electrical power system. This represents the equivalent circuit of a Z parameter representation. And finally, to very vital point, let us not forget this: if we encounter something very useful, both of them, if we encounter a T network like this, then we can straight away write the equivalent Z representation by this formula. Okay, and finally, if we encounter two networks are connected in series, important, two networks connected in series, then equivalent Z parameter is the summation of Z1 and Z2, where Z1 represents the impedance parameter of network 1 and Z2 represents impedance parameter of network 2. So with this I end this part here. From the next part we shall continue discussion, or we shall continue discussing on the remaining parameters. Thank you.